Good morning, everybody. This is first lecture, class FIBSc, paper first, and the name of the paper is Physics Principles and Application here. Today we are going to start the first chapter of the paper first. It is laser here. Why you have to introduce about the laser here? First, we must know here what is laser here. So this is your LASER here. What is meant by L? What is meant by A? What is meant by S and what is meant by E and R here? We must know that here. So laser is nothing but this is nothing but the light. This is nothing but the amplification. It is nothing but stimulated. It is by stimulated emission of radiation here. So here the long form of the laser is light amplification by stimulated emission of radiation here. So this is nothing but the acronym, or it is the long form of the laser here. It is nothing but the light amplification by stimulated emission of radiation here. So here we have to introduce, we have to define some definition from the laser. This is the first chapter, second chapter here. Now here, what is the it is the second chapter actually here. This is the second chapter here. Now here, before that here we must know what is the atom here. We know here this is nothing but the nucleus here. Nucleus contains protons and neutrons here, and electrons are revolving around the nucleus in the circular orbit here. Now how many electrons are there in the different orbit can be calculated by the very simple formula. It is 2n square here. So this is the very simple formula to find out the number of electrons in the different orbit here. So here 2 is the 2 here. The n is the number of orbit here. So for here, for first orbit here, how many electrons are there here? We can easily calculate here. 82n square is equal to 2 into 1 square is equal to 2 here. So there are 2 electrons in the first orbit here. In the second orbit here, how many electrons here? It is 2n square is equal to 2 into 2 square is equal to 8 electrons are there here. In the similarly, in the third orbit here, we can find it here 2n square here. It is 2n square is equal to 2 into 3. It is n is equal to 3 here. So 3 square is equal to 18. 3 square is 9. 9 into 2 is equal to 18 here. So number of electrons in the different orbit can be calculated by this formula 2n square here. Now here this is the introduction about the atom here, and you are familiar with that here. So here this is nucleus here. The definition of the nucleus is it is smallest central massive region of an atom. It is nothing but the nucleus here. Nucleus contains protons and neutrons here. The charge of the proton is positive and neutrons are neutrally charged here. And electrons are revolving around the nucleus in the circular orbit here. So this is one electron, this is one electron here. In the first orbit, there are 2 electrons here. In the second orbit, there are 8 electrons here. So here is electron 1, 2, 3, 4, 5, 6, 7 and 8 here. So these are the number of electrons in the different orbit here. Now we must know that here the number of electrons in the outermost orbit here. So over here the number of electrons in the outermost orbit are called valence electrons here. Valence electron. So here, for example, we consider sodium atom here. So it is sodium here. Atomic number of sodium is 11 here. So we know here what is the how many electrons in the different orbit here? It is 1s2, 2s2, 2p6 and it is 3s1 here. So here in the case of sodium here, there is 1 electron. It is in the outermost orbit here. So here it is 3s1 here. So here it is nothing but the outermost electron here. So this is called the valence electrons here. Valence electrons are in the valence band here. Suppose if you plot the graph here, so it is your valence band here. It is your valence band and it is your conducting band here. It is your conduction band here. Now here the number of electrons in the outermost orbit is known as the valence electron here. Valence electrons are already in the valence band here. Now here if we supply some energy from the external source here, this number of electrons in the valence band goes to the high energy level in the conduction band here. Now they remains in the conduction band for 10 raised to minus 8 seconds and return to the ground state here at its own here. So here this is the transition here. So here this is the introduction. Why we introduce this thing here? Because here we have to define some terms in the laser here. So here first definition is nothing but absorption here. So here this is the introduction about that here. So here the first definition is nothing but absorption here. So here it is nothing but absorption here. What is absorption here? As already I told you that here the number of electrons in the outermost orbit are called the valence electrons here. Now here if we supply some energy from the external source here, the number of electrons for the valence band shifted to the conduction band here. So here this is nothing but this process is nothing but absorption here. So here mathematically we can find out that here suppose it is your valence band and it is your conduction band here. So it is your, for suppose it is your ground state, it is your E1 in the ground state here and it is the higher energy level here. So these are the number of electrons in the atom in the number of electrons in the ground state here. And if we supply some energy from the external source here, this electron goes to the higher energy level here. This goes to the higher energy level here. So here N1 are the number of electrons in the ground state and N2 are the number of electrons in the higher energy level here. So we have to use the another word for that here. This the N1 are the population of the atom in the ground state here and N2 are the population of the atom in the higher energy level here. So here this atom goes to the higher energy level here. This process is called the absorption here. So here what is the process here? When we supply some energy from the external source here, the number of atom or number of electrons from the ground state shifted to the higher energy level here. This process is nothing but the pumping here. So what is the pumping? By supplying some energy, this atom goes to the higher energy level here. This pumping, this is nothing. This process is called pumping here. So atom goes to the ground state to the higher energy level here. This process is known as absorption here. Mathematically, we can define that here. So it is your A is the atom in the ground state here. Now we have to supply some energy from the external source here. So it is your A plus H2 here. So give you A star here. So here A, what is A? A is the number of atoms in the ground state here. H2 is the energy. We have to supply some energy from the external source here. Then this atom goes to the higher energy level here. So A star is nothing but the atom in the ground state energy level here. So again we have to define this equation, this process by mathematics here. So rate of absorption ABS here. So it is the rate of absorption here. So here we know that here. Now here as atom goes to the higher energy level here. For this case here, for this ground state energy level E1 here, it is nothing but the ground state energy level E1. So what happens here? The number of atom goes to the higher energy level here. For this atom, this energy level here, there is the loss in the atom here. So it is given by minus dN1 by dt here. So this is nothing but the rate of absorption, the rate of atom which goes to the higher energy level here. So it is nothing but the minus dN1 by dt here. Now here if we consider the reference level is E2 here, then what happens here? There is somewhat gain in the atom here. In the case of second energy level or higher energy level here, there is somewhat gain in the energy level here. So it can be denoted by, it is dN2 by dt here. We know that here N1 are the population of the atom in the ground state level here. In this equation here, or otherwise we can write this is equation 1 here, and it is also it is equal to it is dN2 by dt here. So it is equation number 1, it is equation number 2, and it is equation number 3 here. So here we know that here A is the atom number of atom in the ground state here. H2 we have to supply some energy from the external source here, and this atom goes to the higher energy level here. A is the number of atom in the ground state. A star is the number of atom in the higher energy level here. Now this equation, another type of way, another way we can define that here, the rate of absorption here. It is equal to, if we consider E1 is the reference energy level here, then what happens here? There is a loss in the atom here. This negative sign indicates that here there is somewhat loss in the atom here. So here how many loss here? It is minus dN1 by dt here. N1 are the number of atoms here. This is loss here because this atom goes to the higher energy level here. So this is nothing but the loss in the atom here. So it is denoted by negative sign here. Similarly, the same fact, if we consider E2 is the reference level here, then what happens here? Now there is, if we consider E2 is the reference level here, then we know that here there is somewhat addition, there is somewhat gain in the number of atom here. So we know that here as N1 are the population of the atom in the ground state here, and N2 are the population of the atom in the higher energy level here. So here it can be defined, same equation can be defined as it is dN2 by dt. There is no any sign here, negative sign here. So there it is the positive sign here. Why it is positive sign here? Because there is somewhat gain in the atom in the higher energy level here. So it is Ra, rate of absorption can be given by, it is dN2 by dt also here. So this is nothing but the gain in the atom here. Gain number of, it is gain of the atom in the higher energy level here. Now this is nothing but the negative side indicate that here this number of atoms are lost here. So negative side indicates that here there is about loss in the atom here. So here this is nothing but the absorption here. This is the definition of absorption here. So here then we have to define the another definition is rate of absorption here. Now here it is spontaneous emission. Spontaneous emission here. So what is the definition of the spontaneous emission here? As I told you that here, so it is your ground state level E1 and it is your higher energy level E2. N1 are the population of the atom in the ground state and N2 are the population of the atom in the higher energy level here. As already I told you that here in the case of absorption, what happens here? We have to supply some energy, then ground state atom goes to the higher energy level here. Now remember here, now the atom goes to the higher energy level, but they remains in the higher energy level for only 10 raised to minus 8 second only here. Then after that what happens here? At its own here, they return to the ground state here. At its own, they return to the ground state here. So this process is called known as spontaneous emission here. This process now here, the atom goes to the higher energy level by supply some energy from the external source here. Then they remains in the higher energy level for 10 raised to minus 8 second here. So here it time is different for different atom here, but averagely we say that here these atom moves to the higher energy level for 10 raised to minus 8 second only here, and they return to the ground state at its own here. So this process is known as it is nothing but the spontaneous emission here. So here now mathematically how can we define that here? As we know that here atom is already in the higher energy level here. Then what happens here? They return to the ground state here. So it is your A here. The energy is radiated in the form of photon here. So it is nothing but the A plus H2 here. So here A star gives you A plus H2 here. So this is nothing but the another equation for the spontaneous emission here. This is equation number 1 and this is equation number 2 here. Now here this equation gives us information that here A star means atom is already in the higher energy level here. Then what happens here after 10 raised to minus 8 second here? At its own here, they return to the ground state here. By now here the energy is radiated in the form of photon here. So it is our equation become here A star gives you A plus H2 here. So it is equation number 2 here. Now here third definition is nothing but the stimulated emission here. Third definition stimulated emission. Now what is the definition of the stimulated emission here? Now as I told you that here. So this is the ground state atom here. Suppose it is your E1, it is your E2, it is your N1 of the atom in the ground state here, N2 of the atom in the higher energy level here. As we know that here, A star is the atom already in the higher energy level here. A star is the atom already in the higher energy level. Now here this atom goes to the higher energy level here. They remain with the 10 raised to minus 8 second only here. And we know that here, in this case here spontaneous emission, we know that here at its own here, they return to the ground state here. Then what happens here? Now here another definition is nothing but the stimulated emission here. Now here by supply some energy here, the atom is tamed. The atom is pressurized here. The atom is pressurized to go to the ground state energy here. So here it is your A star plus H nu gives you A plus twice H2 here. So this is nothing but the third equation for the stimulated emission here. So here they are pressurized here. They are pressurized to go to the ground state atom by supply some energy here. So here A star means here atom is already in the higher energy level here. Then we have to supply some energy by using that somewhat energy here. We have to show that we have to keep that atom here. We have to transfer that atom to the ground state energy level here. So here A star plus H2 gives you A plus twice H2 here. So these are the definition of the absorption. This is nothing but the spontaneous emission, and third is nothing but the stimulated emission here. Now next to that here again we have to define another equation, another definition is it is what is population inversion here. So here we know that here it is what is population inversion here. Population inversion here. Now here inversion means opposite here. Population inversion, what is the definition of the population inversion here? We know that here, so this is your E1 is the ground state energy over here, and E2 is nothing but the higher energy over here. N1 are the atom in the ground state here, and N2 are the number of atoms in the higher energy over here. So first we must know that here what is the equilibrium state here, or what is the normal state here. Actually, what is normal state here? In normal state is nothing but the N1 are always greater than N2 here. So here at normal temperature here, okay, at normal condition or at equilibrium condition here, case here, the population of the atom in the ground state energy level is always greater than the population of atom in the higher energy level here. Then what is the definition of the population inversion here? Now here, if the stage is reached here, if the stage is reached in such a way that here N2 is greater than N1 here, if this situation is reached here, now here by supplies of energy, there is some derivation in the next lecture. We can see that how it is possible here and what is the derivation for that here. So here it is the normal condition here. The population of the atom in the ground state energy level is always greater than the population of the atom in the higher energy level here. Always here. But here, if the condition is reached in such a way that here the population of the atom in the higher level is greater than the population of the atom in the lower energy level here. If this situation is reached here, if this condition is reached here, now this situation is known as population inversion here. How it is reached here? What is the derivation for that here? What is the another stage is reached? What is the another? It is your ground state. It is your higher energy level here. For that here, which another metastable state is reached? We require for that here. Then how it is possible? What is metastable state here? And what is the derivation for that here? That we can see in the next lecture here. So up to that here. So bye. Have a good day. Okay.